Hi YouTube viewers. Okay, here we're carrying out an attempted graphite felt oxidation electrochemically. I have in this bath 0.5 molar sulfuric acid as electrolyte. I uploaded 1 or 2 videos in the past 24 hours on this. Let me show you what I'm trying to do here. And of course, I'll have to collect data and do analyses. But a repeat of the electrochemical oxidation graphite felt. The red, for those that haven't done much electrochemical work with the DC power supply, I'm using constant voltage. And I started about 15 minutes ago, 2.94 volts. Is what I selected, constant voltage, potentiostatic value. And right now at the start, that's 120 milliamps. Evolution of gases. And the anode, the red, the positive, where oxidation occurs. That's where the felt gets oxidized, graphite felt. It's been cleaned, washed very well with distilled water, and then rinsed very well with you can use acetone, isopropyl alcohol, 95% ethanol. This was washed thoroughly with 95% ethanol and dried for 24 hours in an oven, quite arbitrarily at 80 degrees Celsius. So the oxidation of the felt is occurring at the red, the plus, the anode. And of course, the black is the negative, and that's where reduction occurs, and the protons in solution are reduced to form hydrogen gas. You can see the evolution of the hydrogen gas. Now, what's different about this run from the last one I uploaded? The inclusion of a so-called redox mediator, manganese sulfate monohydrate. In the description, I will upload information, the rationale and why I'm doing this. And it is 0.1 molar in manganese sulfate monohydrate. And the redox potential for the manganese sulfate, Mn+2, going up to the permanganate plus 5 is +7. Oh boy. It's a redox mediator. And the potential there for the oxidation half reaction is 1.5 volts. So what I'm saying is it's going to be a shuttle. And the manganese is going to undergo shuttle redox from +2 to +5. But it makes a more uniform oxidizing agent for the graphite felt and can penetrate, we hope. When I get done doing this run, and I'll let it go until the current drops, and as a surface of graphene oxide forms, hydroxyls, carbonyls, epoxies, it forms a passivation level on the surface. And graphene oxide is not conductive, it's an insulator. So it will shut down the electrochemical process once I get a coating of sufficient of the graphene oxide. So I'll be watching the current, and when that drops down, I started, well, it's not going to help you depending on where you are, but I'm in Eastern time, and I started at 1:22 p.m. So let me look at my clock. Of course, time, voltage, surface area, about 25 square centimeter electrodes are used. Each has graphite felt, the cathode and anode. Okay, I'm at little short of 10 of 2. Let's say it's been going, I don't know, roughly a half an hour. So I'll let that go until the current drops. 110 milliamps. And it might take an hour, might take an hour and a half. I did in the first one about 3.5 volts, I think. So we will find out if this manganese salt additive is going to enhance the oxidation of the felt for supercapacitor work. Now, if I'm actually diminishing the conductivity of the felt, which I am by oxidation, why am I doing this? It is becoming more hydrophilic. There are catalytic sites being formed by oxidation. And then we apply composite formulations to the graphite felt for testing in supercaps. I upload a lot of my work now. I'm an emeritus professor at my school. I'm continuing to do research, but I enjoy seeing people getting involved. And there are many home viewers that would enjoy this. And I actually am aware of an electrician who goes home and he does electrochemical work. So that's a real electric warrior. But anyway, very good for undergrads, possibly some high schools, but I definitely think very, very good to get the students involved in energy storage. And we'll let this run. And then when the current drops down, I'll remove the anode felt and rinse it very well, bring it up to about pH 6 or 7. Of course, it's in that 0.5 molar sulfuric acid bath right now, so I want to wash it thoroughly. And remove any manganese dioxide that could be there. And then we will do FTIR, looking for the presence of alcohols, carbonyls, epoxies. And then with our new SEM, scanning electron microscopic imagery, so we can better uniformly quality control from batch to batch. I've done chemical oxidations, sodium persulfate, oxone, O-X-O-N-E, an oxidizing agent used in swimming pools, sulfuric acid with heating. But I like the electrochemical pathway, and I have 2 new undergrads working with me starting this fall term, getting them involved. One is a chem major, the other chemical engineering, and I also have my research colleague who will be graduating this semester, going on to graduate school. So anyway, we'll keep you posted on our work. And we'll see if this shuttle really makes a difference in the performance of the oxidized graphite felt. Thanks for watching, as always. Bye for now.